Hello again. This is part 2 of the CSIR 2301 Exam 2 review. We have done parts 1 earlier, which covered questions 1 through 7. And I ran out of room, so we're going to start all over with 8 on this one. Well, not all over, but starting with 8. In number 8 and 9, I'm just going to briefly cover because we have not really talked about those yet. 8 states to identify the schematic representation of the common emitter, common base, and common collector emitter follower, in other words, circuit configurations. That's some of the stuff I've posted online, but we'll cover that even more in detail later. 9, state the principal operational characteristics of bipolar transistors used in the common emitter, common base, and common collector or emitter follower circuit configurations. Again, this is where we kind of left off with 8 and 9. We have not talked about those yet. Now, on 10, though, we have, and I'm going to slide another sheet of paper in here, and I will get used to doing this eventually, maybe. Number 10 we did talk about earlier, and it says, explain the basic behavioral difference of germanium, the GE, and silicon bipolar transistors. And what we know is germanium is a weaker type material, so we can actually get it to conduct somewhere between 0.1 volt to 0.3 volt, or 1/10 to 3/10 of a volt. Because it is a little weaker, it is more heat sensitive. Where silicon, it's bonded together a little bit stronger, so it takes somewhere between 5/10 to 7/10 of a volt, or half a volt to 7/10 of a volt, for that to actually conduct and operate. And that's the part that we're looking for number 10. 11, we have, we did this in lab, where you actually went in, it says explain the basic behavioral difference. I'm sorry, I'm on the wrong question. Explain how to test PNP and NPN bipolar transistors using the ohmmeter and transistor tester. We did this, quite a bit of this. We used the labs, and then we also utilized ETCI to begin with. This is where we looked for the forward bias or the reverse bias of the junctions. So we was looking for a high-low, high-low. I'm going to go back to page 1 just for a minute, and I'm going to look at the NPN here, because we can use this one to show what we did, what we actually set up for. And I'm using the NPN because, again, and this is a test question, that's why I keep saying that, the NPN is the most common bipolar transistor that we utilize. Hint, hint. But when we measure between the emitter to base, we look at that exactly like it's a transistor. And this is the PNP, NPN. This one is this one. So just kind of holding it together here. So hold it out a little bit so you can see what I'm talking about. If I put a negative here and a positive here, I would forward bias that junction, so I should get a low reading. A negative and a positive would forward bias that and give it a low reading. If I reversed it and put a negative here and a positive here, that's reverse biasing it, and we should get a high reading. And we're using the battery, remember, the ohm meter, to bias this. So here, if I put the positive here and a negative here, that would be low. Positive here, negative here, that would be low. And so we should get a low forward biased and a low forward biased and a high reverse biased and a high reverse biased. And this junction, because that material here is in the middle, either way we go, whether we put negative or positive on either side, it would always give us high, as long as the transistor is good. If it's not, if we got a low, then it would be a short, and if it's open, it would be a high. If you need more practice on that, you can go to the ETCI. Remember, we did that, the very first one, where you could actually forward and reverse bias transistors and see if they were good or bad. We're going to go to number 12 real fast, because that's one we have not covered yet. 12 says explain the meaning of HFE and the H, capital F, capital E, and HFE. We've not covered that really. In 13, we have not covered yet. 14, explain the meaning of bipolar. We have talked about that. That means the bipolar means two carriers, two majority carriers are inside of a bipolar transistor. And so that is why it's called a bipolar. State what controls the bipolar transistor. Remember I said earlier, we've said this a dozen times. I know, really a million times. But this is the emitter base current that controls this device. It's the emitter base current that controls this device. And 15, explain the bipolar class A, B, and C operations when they are used, and we have not covered that yet. We will be covering these. Number 17, we have not covered either. So what this video should be doing here should actually be catching us up on where we left off. And then when I start lecturing again, we will be covering what we have missed. You will see that I will be posting homework assignments and things like that to help support what we're doing.